So example 4.2.4, calculating a theoretical probability. So suppose you have an iPod Shuffle with the following songs on it. So we got a long list here. So we got 5 Rolling Stones songs, 7 Beatles songs, 9 Bob Dylan songs, 4 Faith Hill songs, 2 Taylor Swift songs, 7 U2 songs, 7 Mariah Carey songs, 7 Bob Marley songs, 6 Bunny Wailer songs, 7 Elton John songs, 5 Led Zeppelin songs, and 4 Dave Matthews Band songs. So you have a really interesting taste in music with all of those different bands. All right, the different genre that you have are rock from the 60s, which includes the Rolling Stones, Beatles, and Bob Dylan, country, which includes Faith Hill and Taylor Swift, and rock of the 90s, which includes U2 and Mariah Carey, and reggae, which includes Bob Marley and Bunny Wailer. Okay, rock of the 70s includes Elton John and Led Zeppelin, and bluegrass rock includes the Dave Matthews Band. A lot of information in that one little paragraph there. All right, so the way an iPod Shuffle works is it's going to randomly pick the next song, so you have no idea what the next song will be. Now, you would like to calculate the probability that you will hear the type of music or the artist that you're interested in. The sample set is too difficult to write out. It's not horrible, but there's a lot of numbers in there, and really we can just figure these out by going back up to the paragraph and just grabbing the numbers we need, keeping in mind that they were nice and actually added all of those up for us and told us that the total number of songs you have is 67. So Part A asks us for the probability that you will hear a Faith Hill song. So our experiment here is it's just going to, randomly select one song from your list. All right, so the probability that we're going to hear a Faith Hill song, so there are, if we're looking at, so I'm just going to, let's see here, you will hear a Faith Hill song. Let's just call that event F for Faith Hill. So our probability that we hear a Faith Hill song, we're going to go back up to the paragraph and count up, and they told us up there that we had 4 Faith Hill songs. And they told us the total number of songs was 67. So the probability that we would hear a Faith Hill song when it randomly just generates a song would be 4 chances out of 67. All right, Part B asks us for the probability that you will hear a Bunny Wailer song. So let's just let that be our event B. And so again, if we go back up to the paragraph, there were 6 Bunny Wailer songs. So the probability of this event B occurring would be 6 chances out of 67. Okay. Again, the fact that they're randomly chosen is important here. That makes them all have an equal chance of being chosen. So maybe we should put that up here. So this randomly picks piece is important. This is what allows us, we can use the equally likely rule. Versus if you were taking requests or searching for particular songs or types of songs that you want to hear, then they would not all have the same chance. All right, so for Part C, we want the probability that you will hear a song from the 60s. Okay, so again, we're going to take, you will hear a song from the 60s, and we'll define that as our event C. So if we go back up to the paragraph, they said songs from the 60s. Let's see, you have rock from the 60s, which includes Rolling Stones, Beatles, and Bob Dylan. Okay, so the 60s we had Rolling Stones, Beatles, and Bob Dylan. And so back up in the paragraph, if we look at those, there were 5 Rolling Stones, 7 from the Beatles, and 9 from Bob Dylan. So if we add those all together, we get 21, and out of our total of 67 songs. So the probability that we would hear a song from the 60s, if we just randomly pick a song out of these 67, would be 21 chances out of 67. All right, part D asks us for the probability that you will hear a reggae song. So I don't know, let's define that as like event R here. So if we go back to the paragraph, it said that reggae includes Bob Marley and Bunny Wailer. So Bob Marley and Bunny Wailer. And if we go back and look at those, so Bob Marley, we had 7 songs, and Bunny Wailer had, let's see, what did we have? We had 6. So the probability that we would hear a reggae song, so this is a total of 13, would be 13 chances out of 67. Part E says, what is the probability that you will hear a song from the 90s or a bluegrass rock song? So again, or means we have to be in at least one of the categories. So a song from the 90s, so if we go back up to the, let's see, paragraph, this was U2 and Mariah Carey. And bluegrass rock was the Dave Matthews Band. So again, if we go back and look at our song titles from the 90s, we had, so let's just call this event that we're interested in here. I don't know, what letter haven't we used yet? Maybe a D. Probability of event D. If we go back up to the paragraph, and let's see, there were 7 U2 songs and 4 Mariah Carey songs. And let's see, and there were 4 Dave Matthews Band songs. So we're going to get 7 plus 4 plus 4, all out of 67. Okay, so that gives us 15 chances out of 67 for this event to occur. Okay. Part F asks us for the probability that you will hear an Elton John or a Taylor Swift song. So again, we have the word or, so it's got to be in at least one of the categories. Okay, and currently we don't have any songs out there that Elton John and Taylor Swift are singing together. All right, so the ones that meet the category of being sung by Elton John, again, if we go back to the paragraph, there were 7 of those. And Taylor Swift, there were 2. So that means if we call this event E, our probability of hearing an Elton John or a Taylor Swift song would be 7 plus 2, which is 9, out of 67 chances. All right, so again, lots of examples here, just trying to get used to the wording of ors and ands and how we're looking at the categories here. All right, so what is the probability that you will hear a country song or a U2 song? Okay. So again, if we go back up to the paragraph, there were 6 country songs, and U2, there were 7 songs by the band U2. So again, if we call this, I don't know, event F, there are a total of 13 out of 67 chances of hearing either a country or a U2 song. So now, if we go back to the previous example, it was mentioned that the probability of an event D plus the probability of event C was 1, okay, where this was getting an ace and not getting an ace. This is because these are 2 events that have no outcomes in common. Okay, so there's no card that's both an ace and not an ace at the same time. And together they make up the entire sample space, meaning every card has to be either an ace or not an ace. It's got to be in at least, it has to be in exactly one of those 2 categories, is how we can summarize the fact that they have no outcomes in common and together they make the entire sample space. So events that have this property are called complementary events. And so we're going to use the fact that sometimes to get the probability of some event happening, it's easier to compute the probability it doesn't happen and then subtract from 1.